Hi, today we're going to have an introduction to matrices, and you can watch some of the further lessons to learn more. Okay, so what is a matrix? A matrix is basically an array of numbers in which you can represent a system of equations, but only using the coefficients. So for example, if you have the system of equations, if you have this random system of equations, the way that you would represent this in a matrix form would be taking just the coefficients and writing them in square brackets, like so. Great, so now you have your very first matrix. So, when are matrices used? Well, before, you know how to add, subtract, and substitute this system of equations to solve for the variables x, y, and z. But now we can use this array of numbers, the matrix, and we can use these coefficients to find a more efficient and a more effective way to solve systems of equations which may have more variables or may have more complex numbers with which you couldn't necessarily use the other three methods to solve. So the first thing we need to know about a matrix is the order. So for example, how would this matrix be ordered? So when you're trying to find out the order of a matrix, you want to figure out the row and the column. Now, you always say the row first, and then it's followed by the column. So, if it's row by column, if it's in a row by column form, you know that you have 1, 2, 3, 4. You have 4 rows, and you have 1 column. So you know that this would be a 4 by 1 matrix. Now this, if you use the row by column form, it would be a 1 by 4 order matrix. Now, any order of a matrix can be simplified to simply m by n, where m is the row and n is the column. Now, when you want to refer to the individual values, so the individual coefficients of the system of equations that you had, you need to have some kind of method of numbering them, just in case you need to figure that one out. So for example, I'm assuming that, now it's 2009, almost 2010, everyone has seen Windows Excel, or sorry, Microsoft Office Excel, right? So it's a very simple and a very similar way of ordering. So you know that, by now you know that you're always figuring out the number for a matrix row by column. So the same thing, you number them row by column. So for example, A here would be in the first row and in the first column. So if you want to figure out a number that is in 1, 1, you know that it's A. If you want to figure out one that is in the first row, second column, it's B. Now, second row, first column is D, and so on. So it's simple, just like the spreadsheets, where you're naming the individual cells by where they are in relation to here. Now, if you have a great value of numbers, so for example, you're naming something that is in the position of 13, 6, it is a good idea to put a comma in between these two numbers because if you write it 1, 3, 6, it can mean that it's in the first place, first row, 36th column. You know, it could just be incomprehensive. Now, let's try a few examples with the following. Now, whenever you're working with matrices, you always have the matrix as one variable, such as b in this case. Now, this is for many reasons, one of which would be that rather than referring to the individual ones, you want to refer to the whole matrix. Now, a second one, if you're doing different operations with matrices, as you will see later, you need more than one variable to account for the whole matrix, for example, adding, subtracting, finding the inverse, and whatnot. Now, third reason, when you're trying to figure out where the individual values are inside this matrix, you're writing the value as, for example, if we want row 1, column 1, B1, 1. Now, as you previously learned, what would that number be? 3. Very good. So try and figure out what B2, 1 would be, and what B4, 1 would be. So for 2, 1, you know that it's in the second row, and it's in the first column. So this one would be 4. And for the fourth row in the first column, we don't have a fourth row, so it's nothing there, so you do not have a value. Right. So just some basic terminology that we want to remember from this lesson. If you have a matrix which has the same number of rows and the same number of columns, it's called a square matrix. So basically, when m is equal to n, and you know that m is the number of rows and n is the number of columns, it's called the square matrix. When all the elements inside the matrix are 0, then we call it a zero matrix. Now, when a matrix has only one row, so in the example that we had before, when let's say matrix C is equal to 4, 3, 1, 2. When we have this situation, when there's only one row, we call it a row vector. And when you have a matrix that only has one column, we just call this a column vector, or just simply a vector. Now you might be wondering where you would use matrices. Now, matrices can be used anywhere from solving a system of equations, optimizing problems in linear programming. There are many chains involved, predicting probabilities, many things like that, as well as maximizing costs, minimizing costs, maximizing output, interpolation, extrapolation of different materials, and you're going to have to know it at some point, so you might as well learn it now. Okay, thank you. Check out some of my other videos on YouTube.